Yeah, let go. Okay, guys, good morning. Today, inshallah, we'll take lesson 4, page 539, compare probabilities of simple events. Now, before we start, guys, if you have any questions or any idea you didn't understand, you can ask me about the previous homework or the exercises which we did on Thursday. Okay. Now, what we did in the previous lesson, guys, we found probability of simple events. Simple events. Today, we will compare between them. For example, in the previous lesson, we did, for example, if we have this spinner here, and it is have these sections, let's say with 1, 1, 2, 3, 4, 5. And I spin it once. What's the probability to have 1? I will count how many ones we have. We have 2 ones. Over how many sections we have? 1, 2, 3, 4, 5, 6 over 6, which is 1 over 3. This is what we call it simple event. Simple event. For example, if we flip a coin, what is the probability to have head? If we flip a coin once, the coin, if you flip it, either you have head or tail. So what is the probability to have head? How many heads we have? 1.
1
The
over 2.
total 2. So it is half. Don't talk, Yabni. Don't talk without permission, please. So guys, what we call these, we call them simple events. Simple event, to find the probability of simple event, we count how many the favorable outcomes we call them, which is what the question wants, over the total elements of the sample space. This is what we call it sample space, right? What is the sample space? Is the all possibilities of the results, all possibilities of experiment or a trial, okay? So what we did in the previous lesson, we call it simple events. And we focused on something, we call it complement of the event. How to find the complement of the event. So if P equal a number, let's say 1 over 3, and we want the P complement, which is equal, we said 1 minus the probability, which is 1 minus 1 over 3. If you subtract, it will be 2 over 3. So we did 2 ideas. How to find the probability of simple event by counting, and how to find the complement of the events, okay? Today we will compare probabilities of simple event. We will compare between them. Means if we have 2 experiments at the same time, 2 experiments at the same time, okay? For example, look here at the board, please. Look at the board. If we have 2 experiments at the same time, like here, flip a coin. And here I will flip, I will choose a number from these numbers. Okay, here I want probability of head, probability of tail. Here I want probability of 1, probability of 2, probability of 3. So here we have 2 experiments at the same time, and we want to find probabilities. If we flip a coin, probability of head, it is half, 1 over 2. Why? Because in the coin we have 1 head and we have 2 answers, head or tail. Also, probability of tail also is 1 over 2. Because we have 1 tail and 2 outcomes of the coin, which is head or tail. Here we have probability of 1, it is 2. We have 2 ones, right? 2 over 1, 2, 3, 4, 5, 6, 7, 2 over 7. Probability of 2 also, we have 2 2s, right? So also 2 over 7. Probability of 3 also, no, not also, it's 3 over 7 because we have 3 3s, right? Here we have equally probabilities, so we call it evenly. Evenly, without this in. Evenly. Here we have different. Evenly means they have the similar probabilities. Different probabilities, different, depends on the numbers, depends on everything. So we can compare between probabilities with simple events if we have two different experiments. So to compare, we need to find probabilities, then see what's the difference comparing. For example, if I have the dice, you know the dice, 1, 2, 3, 4, 5, 6. We know the dice. If we flip it once means one time. But what is the probability to have 1? What is the probability to have 2? To have 3? To have 4? To have 5? To have 6? The probability to have 1 here, we have only 1, right? How many ones we have? 1 over 6. To have 2, we have only 1, 2 over 6. Oh, sorry, 1 over 6. To have a 3, how many 3s we have? 1 over 6, 1 over 6, 1 over 6, 1 over 6. This what we call it evenly. From even. Even in Arabic words, not even numbers, 2, 4, 6. No, we have different concepts here. Even like same, equal. Like in Arabic words, متعادل, fair, I think. I'm not sure. Fair, yeah, fair enough, yeah. So evenly happened means the simple events here have the same probabilities. Same probabilities. This is the idea of this lesson, how to compare between probabilities of simple events if we have two different experiments. This is the idea. Let's go to the lesson, guys. We are on page 539. Please open your books because we'll use the book a lot today, okay? We are on page 539. Prepare your books, guys. Let's go to example 1, page 541, guys. All of you go there, please. All of you go to example 1, page 541, please. Yeah, let's read together. And look at your book, guys, not on the screen, because sometimes the screen is not clear. So please, guys, look at your book, okay? Read, ya Mustafa. Focus, guys.
Yes, okay. A tetrahedron is a three-dimensional figure with 4 equally likely outcomes.
Look here. This one, see this one?
Yeah.
What? Tetrahedron. Tetrahedron. I don't know if I say it correctly.
Yeah.
Tetrahedron, whatever. So we have here 4 or a 3-dimensional figure with 4 equally likely outcomes. Yani, like the dice. The dice has 6 faces. This tetrahedron has how many faces? 4 faces.
4.
And what are the numbers in the 4 faces? 1, 2, 3, 4. They said from 1 to 4. Khalas?
Yeah.
So the first experiment, guys, this tetrahedron with 4 faces, and the answers or the numbers labeled or the faces labeled from 1 to where? To 4. Similar to the dice. The dice is from 1 to 6. You know the dice. Here we have similar idea, but from 1 to 4. Got it, ya Mustafa?
Yeah.
Yeah, this is example 1, guys. Page what?
Page 541.
41. Hello. So this is the first part of the question. 4 faces from 1 to 4. Got it?
Yeah.
The second part. What?
This is spinner. Yeah.
Identified by. Yalla, continue. ماشي.
Identified by the number showing at the top vertex.
حلو.
Maribel tosses the tetrahedron shown 50 times, while
حلو.
Dalton spins
لا لحظة شوي، لحظة. عندنا ماربل، هذا لمين هذا؟
Maribel.
لماربل، right?
Yeah.
And she tossed this tetrahedron how many times? 50 times. خلاص? I'm analyzing the question, guys. So this is the first experiment. We have tetrahedron with 4 faces labeled from 1 to 4, and Maribel tossed this tetrahedron how many times?
50 times.
خلاص? The second part now, يلا.
While Dalton spins the spinner shown 50 times.
حلو. We have the second one here, the spinner. See the spinner, guys?
Yeah.
It's weird. In the spinner, شو اسمه هذا تبع السبينر؟ دالتون، right? دالتون يا ابني اسمه؟
Yeah.
يا
Dalton.
ابني خلك معي، الله يسعدك، ركز. Dalton make this spinner, and the spinner, look at the spinner, guys. Something like this, right?
Yeah.
The spinner has 1, 2, 3, and 4, right? But
yes.
I want to ask a question before I continue here. What is the probability to have 1 here? Once.
1/4.
1/4. To have 2?
1/4.
To have 3?
3/4.
نعم؟
1/4.
ركز. 1/4. To have 4?
Also 1/4.
1/4. So here we have evenly happened, right? Means if we toss this tetrahedron once, each one element here has the same probability to happen, the same chance, right?
Yeah.
But here, do we have the same chance for 1, 3, 2, and 4? For the spinner?
No, because 3 and 4 are
because they are not evenly separated or divided, right?
Yeah.
Means the probability to have a 3 and 4 is bigger than the probability to have 1 and 2, right?
Yes.
So Dalton spins this spinner how many times also?
50.
50 times. Good. So these are the 2 experiments for Maribel and for Dalton. خلاص?
Yeah.
طيب. Let's take a look to the 2 graphs down. To the 2 graphs down, okay? Student 1 and the student 2. See them?
Yeah.
I will make close figures to them here. ركز معي. Not only you, all of you guys. I will graph the 2 figures down here, okay? I will graph similar for them. Here, 1, 2, 3, 4. 1, 2, 3, 4. My question is, which one of them for Maribel and which one of them for Dalton and why? Who can tell me? Tell me, Mustafa, which one of them can be for Maribel? The first one or the second one?
I think 1.
علي صوتك يا حبيبي، صوتك نايم.
I think 1.
This one is for Maribel.
Yeah.
Good boy, but it's incorrect. It is mistake. It is wrong. Who can tell me why? Why this one cannot be for Maribel? Who can tell me, guys?
I know, Mr.
طيب عبد الله.
Oh yeah, Mr. Okay.
Wait يا ابني, wait. عبد الله. Abdullah Riyad.
Yes, Mister.
Why this one? Mr. Mustafa said this one can be formable. I said no. Why? Can you tell me why this one cannot be formable?
Yes, because in the spinner, the 3 and 4 have a greater chance, and the student one have the chart say that 3 and 4 have more to, the face that went for 3 and 4 is more than 1 and 2.
Good. 3 and 4 has the biggest chance to happen. More than 1 and 2, right?
Yes.
So logically here, I'm talking about logic, okay? 3 and 4, because it has bigger chance to happen, it has more answers or more outcomes here. But here, the 4 elements or the 4 numbers have the same chance to happen, 1 over 4, 1 over 4, 1 over 4, 1 over 4. So they are close to each other. No difference between them. If you have difference, it will be small one. So logically, the first one, student one, will be Dalton, and the second one will be formable. Mustafa, are you with me? Hello?
Mister, I think he muted himself.
ليش يا زلمة؟ لا يكون زعل.
No, maybe my mistake.
No, Mr.
It happens.
Mustafa, are you with me?
Yeah.
Do you understand it?
Yeah. I thought
So
like
I
it
did
felt
everything,
something else.
guys, without continue the example. I just did it by logic, okay? Now let's go to the example and see how they explain it together. Please read with your friend. Continue, Mustafa.
Okay.
Neither
Neither Marble nor Dalton wrote their name on their graph.
means
Which
in the graph, guys, they wrote student
unknown.
1, student 2. We don't know before we answer the question. We don't know which one for Dalton, which one for Marble, right? They just make their experiments 50 times for each and record their answer, their results, right? And we don't know. Continue.
Which graph best represents the results that can be expected from Marble's experiment, Dalton's experiment?
Yeah, down here we talked about these two figures. Now down in Marble's.
In Marble's experiment, the tetrahedron has outcomes that are equally likely.
That's equally likely. Remember, guys, find likelihood. Equally likely to have 1, same chance to have 2, same chance to have a 3, same chance to have 4, right? Which is similar to this. They have a close chances. To have a 3 and 4, likely. To have 1 and 2,
unlikely.
Unlikely. Remember, connect this answer or this example with the first lesson of this chapter, find likelihood. Here, all of them are likely. 50-50, نفس الchance إلهم. But here, 3 and 4 likely and 1 and 2 unlikely. Got it? That's why 3 and 4 likely, 1 and 2 unlikely. But here 1, 2, 3 are 4, 3 and 4 have close chance to happen. Continue.
The observed results are likely to be more evenly distributed.
Evenly means fair. Fair means
or Mister, you can say draw.
fair. You know fair?
Yeah.
يعني عادل. عادل. Okay, good. Continue.
Okay. The graph for student 2 best represents Marble's experiment.
So student 2 represent مين حكينا؟ Marble, right?
Yeah.
Continue. In Dalton's
experiment, the spinner's section level 3 and 4 are each greater in size than the section levels 1 or 2.
حلو.
The observed results are likely to have a greater frequency for these two outcomes.
مين هم؟ مين؟ The 3 and 4 have a greater probability, right?
Yeah.
يلا. So
the graph for student 1 best presents Dalton's experiment.
This is example 1, page 541. Now, all of you remove your hands, guys, please. If you have any question about this example or the general idea, just ask me. Please. If you have any questions, just ask me. Omar or Iyad?
Sir, I wanted to answer, but I don't
Wait, Omar, you want to answer? Iyad? علي صوتك حبيبي. جايز ليش صوتكم ضعيف؟ أنا مش عارف يعني. علي يا ابني صرخ. يلا.
بدل ما تقول evenly تقدر تقول balance.
I cannot hear you والله.
He says instead of saying even you can say
خليني
balance.
أسمع يا عمر معلش. عمر لو سمحت.
Okay.
إياد توك حبيبي.
بدل ما تقول evenly تقدر تقول balance.
Sir, he is saying instead of saying even you can say balance.
لا يا حبيبي صوتك مش عالي أنا مش سامعه.
Sir, I'll say. He says you can say instead of evenly you can say balance.
You can say what?
Balance.
Balance.
No, I want to say evenly. Okay?
Okay.
Iyad, okay?
Okay.
Good. Else يا إياد.
ولا حاجة خلاص شكرا.
Mr. Omar.
Sir, I just wanted to answer a question.
يلا, go to the check. We have checked, guys, page 542. See it? Let's do it together here. يلا. Read.
Check. Jaden and Nahal each spin their respective spinners shown 50 times. They each record their results in a
Jaden,
frequency.
معلش. Jaden has this spinner and مش عارف من وين بيجيبوا هاي الأسماء. نخل whatever spins this one. How many times both?
50 times.
So Jaden spun this spinner 50 times and Nikhil spun this spinner 50 times. Continue.
They each record their results in a frequency per graph.
Hello. Neither
Jaden nor Nikhil wrote their name on their graph. Which graph best represents the results that can be expected from Jaden's experiment, Nikhil's experiment?
Hello. So before we are going down, okay, let's take a look here, guys, in the two spinner. And let's take a look to the Jaden spinner first. And please, guys, see it in your book. And try to listen to me at the same time. For Jaden, what we have different here, yeah, Omar, tell me. What you notice here, what's your note? They are not equal. And for 1 and 2, we have less, what? Chance to happen, right?
Less chance, yes.
Less chance. But in Nikhil spinner, they are all what? Evenly, or they have the same chance to happen, right? Means here we have likely probability, right?
Yes.
Here, unlikely for 1 and 2, and the others are likely, right?
Right.
Now let's take a look to the two graphs down. Which one should be for Nikhil and which one should be for Jaden? Logically, I'm talking.
Nikhil will be for student 1 because they're all equal, and in student 1 you can see that the frequency is likely.
Good. In student 1, guys, 1, 2, 3, 4, 5, and 6 have a closed chance to happen, right?
Right.
Close, not equal. ما احنا ما بنعرف. يعني here the one how many times? Look at the first one. How many times?
8.
It is between 8, yeah. The 2, 9.
2
The
is
3, 11. The
11.
4, لأنه
9.
هو 50 times, right?
Yes.
But here, the 1 and the 2 has
Or low.
very smaller than the others, right?
Yes. And 4 and
So,
6 have high.
exactly. So, Nikhil should be what?
With
Student
student 1.
1. And the student 2 should be mean?
Jaden.
Jaden. So, your answer will be, guys, copy or write down here in your space. Let's read how they explain it. Okay? Simple answer. In Jaden's experiment, the spinor section labeled 1 and 2 are each similar in size in the other sections. Okay? The observed results are likely to have lesser frequency for these two outcomes. So in Jaden, 1 and 2 have less frequency. In Nikhil, all of them have the similar frequency. So, copy, just write Jaden
Mr. Jaden
and
is a
Nikhil.
student.
Yeah. Jaden is which one? 2, right? And Nikhil is student
1.
1. Any questions, guys, about the check?
Mr. Rami,
Yes.
they say explain your reasoning.
Yeah, explain why Jaden is a student 2. Tell me you, why?
Because 1 and 2
Because
No, I'm asking Yazan. Why Yazan? Why? مش explain your reasoning means you need to explain your answer, right?
yes,
Explain it by your own words. Why Jaden is a student 2? Tell me.
because Nakhel, the frequency is
No, I'm asking about Jaden, mister. Why Jaden is a student 2?
because the results is not equal.
مش شرط يكونوا equal. ما هو لحظة. It's not a condition to be equal, right?
Yes.
مش لازم يكونوا equal. They have equally chance to happen. But if you spend 50 times لازم كل واحد يكون قد الثاني؟ لا مش شرط. So why? Why Jaden? We choose it for student 2. I will tell you why. Because student 2 for Jaden, because 1 and 2 has less chance to happen, and this is obvious in the graph. مش equal. طب هذول equal هذول؟ لا. مش equal. You spend 50 times. The 6 becomes 10, the 5 becomes 11, the 9. But by looking, student 2 should be Jaden more logically. It is not exact answer. I'm talking about logical here, okay? Logic. بس. Do you understand it, Yabni?
Yes.
Good. Why Nikhil is student 1? Because we say, because the graph shows that the 4 sections have the same, or the 6 sections as have likely or fair chance to happen. That's why they are close to each other. But in Jaden, we have different chance to happen, okay? This is the check page for 541. Any questions, guys? Any questions about the idea of this lesson? Abdullah.
answer. I wanted to answer.
Do you understand it يا ابني؟
Yes.
طيب محمد حسن. محمد. وليد.
Also, I want to answer.
Do you understand everything?
Yes.
Right. Let's see your homework, guys, for today. Let's see your homework for today. You will read the question and see the two choices here. And you read the question and see the two choices. And see what the question wants and try to compare and get the answer, okay?
Yeah. Mr. Only I was want to answer, okay? Muhammad Hassan.
ماشي. Do you understand it يا ابني?
Yeah.
Good. Good. Any question, guys?
No. I don't have a question.
If you don't remove your hands, please. Abdullah. Any questions, guys? Ask me. Not only about this lesson, about any idea before. That's all for today, guys. Hope you understand it very well. Thank you so much. Do your homework and send it to Classera. Tomorrow we'll discuss the answers and check it together, inshallah. Thank you so much
Okay.
and have a good day. Goodbye.